is Heaviside unit function, and we are studying Laplace transforms of Heaviside's unit function. Let's get to the definition. The unit step function is defined as, the notation is u of t minus a, and it is defined to be 0 when the value of t is less than a, and it is defined to be 1 when t is greater than or equal to a. It is also called as Heaviside's unit function. Okay, it looks like this. A is the breakpoint. When the value of t, this is the t-axis, when the value of t is less than a, the function is defined to be 0. And when the value of t is equal to a and greater than a, the function is defined to be equal to 1. Therefore, this is unit step function. The value is unit value. Therefore, it is called as Heaviside's unit function. In particular, when the point A is chosen to be 0, then we write the function as u of t. Then the value is like this: u of t is 0 when t is less than 0, and u of t is 1 when t is greater than or equal to 0. This is greater than or equal to 0. Therefore, this function is called as Heaviside's unit function. We will study the Laplace transforms of Heaviside function. Find L of u of t minus a. U of t minus a is nothing but the Heaviside function. We will use the definition. By definition, it is integral 0 to infinity e power minus st. U of t minus a is the function into dt. Since the function is defined in two parts, from 0 to a and from a to infinity, therefore we will divide the integral from 0 to a and from a to infinity. The breakpoint in the function is a, therefore we'll split the integral at a. Now from 0 to a, the function is the same, integration of the same function plus integral a to infinity, integral of the same function. From 0 to a, the function is defined to be 0, and from a to infinity, the function is 1. Therefore, we have this integral. This integral, it is 0 here, therefore the integral becomes 0. And integration of the second one, e power minus st, becomes e power minus st by minus s. In this integral, t is the variable of integration and s is treated to be a constant. In that case, it becomes e power minus st by minus s. And the limits are from a to infinity. Apply the upper limit and the lower limit. Minus 1 by s is taken outside. This becomes e power minus infinity minus e power minus t is substituted as a, therefore e power minus sa. E power minus infinity is 0, therefore this becomes, after multiplication, 1 by s into e power minus sa. Therefore, the Laplace transform of Heaviside function is 1 by s into e power minus sa. This is a formula to be remembered for all the further problems. The second problem, if the Laplace transform of the function is f of s, capital F of s, then prove that L of f of t minus a into u of t minus a is equal to e power minus as into f of s. That means, if the Laplace transform of this function f of t is known to us, then the Laplace transform of f of t minus a into u of t minus a is equal to the same value of the Laplace transform I have to multiply by e power minus as, where u of t minus a is the unit step function. We will use the definition to prove this. L of f of t minus a into u of t minus a. By definition, it is integral 0 to infinity e power minus st into f of t minus a into u of t minus a dt. As before, because the function u of t minus a breaks at the point a, we will break the integral from 0 to a and from a to infinity, integral of the same function. Substitute for u of t minus a. From 0 to a, the value is 0, and from a to infinity, the value is 1. Therefore, this integral vanishes and we have integral a to infinity e power minus st into f of t minus a dt. Now, to evaluate this, what we shall do is, I want to put it in the form of integral of, because L of f of t is known to me, I want to put it in the form of L of f of t. That means I need 0 to infinity e power minus st into f of t dt. The variable here is different, t minus a. Therefore, for this variable t minus a, I will do a substitution v. Put t minus a is equal to v. Therefore, dt This differentiation is 0 because this is a point. Differentiation is 0 is equal to dv, and t is equal to b plus a. Now we have to change the limits when we use substitution method. Therefore, when t is equal to a, here it becomes a minus a is equal to v, that is v is equal to 0. When t is equal to infinity, v also is equal to infinity. Therefore, we will do the substitution in the integral. The limits are from 0 to infinity now. E power minus s into t is substituted as v plus a. So this is v plus a. T minus a is substituted as v. Therefore, f of v dv. We will split this integral e power minus sv into e power minus sa. We will open the bracket and use the formula e power a plus b is equal to e power a into e power b. Now we will analyze the powers here. V is the variable of integration, a is the constant, and s has nothing to do inside the integral with respect to v. Therefore, this can be taken outside the integral. Therefore, e power minus sa into integral 0 to infinity e power minus sv f of v dv. Now, this is the definition of L of f of t. As said before, the variable of integration does not matter for us. The value of the integral is going to be L of f of t. Therefore, L of f of t minus a into u of t minus a is equal to e power minus sa into L of f of t. This is the formula which we wanted to derive. From here, we have another application. So that if L of f of t is equal to this one, L inverse of the second term is equal to the first term, f of t minus a into u of t minus a. Therefore, I can find the inverse Laplace transform of e power into some function using my unit step function. Okay, slowly we will go into different kinds of problems. Express the following function in terms of unit step function and find their Laplace transforms. Okay. I have to express this function in terms of unit step function and then I have to find their Laplace transform. So I will start with f of t. We express f of t in terms of unit step function. Now the breakpoint here is pi. Therefore, I have to express in terms of unit step function u of t minus pi. And what will be u of t minus pi? Because pi is the breakpoint over here, it will be 0 for t less than pi and 1 for t greater than or equal to pi. So I will start with my f of t. I take the first part of f of t. I will write this f of t as 2t minus 2t into u of t minus pi. I want to bring in u of t minus pi. Therefore, I will start with the first half 2t minus the same thing into u of t minus pi. And I will check what is the value of this function. If the value of the function and the given function and this function is same, then we have already expressed in terms of unit step function. Or else I have to do few more iterations to add in match with the given function. So if I write f of t as 2t minus 2t into u of t minus pi, then what happens to this value we will see. If t is less than pi, then this function is going to be 0. So in this function only 2t is left. Therefore, if t is less than pi, second part is 0 by definition of u of t minus pi, and therefore f of t will be equal to 2t. If t is greater than pi, then this function is going to be 1, so that it is 2t minus 2t into 1, therefore 2t minus 2t becomes equal to 0. Therefore, the new function what I have defined is this, f of t is 2t when t is less than pi and 0 when t is greater than pi. Now we will compare the given function and this function. First half is same, but the second half I want it to be 1. But if I define like this, I get it to be equal to 0. So first half is right. The second half I have to change so that these two functions will be same. This is the same as the given function when t is less than pi. We need to make f of t equal to 1 when t is greater than pi. Therefore, we will take the same function and make few iterations again. Now what is the iteration we need? Set f of t is equal to 2t, which is same, minus 2t into u of t minus pi, that is same, plus u of t minus pi. Why we do this is, I take the second part and multiply by u of t minus pi. Now we will see what happens. Will it match the given function? Now, when t is less than pi, u is going to be 0, u is going to be 0, therefore only the first term 2t is there. When t is greater than pi, this is going to be 1, this is going to be 1, therefore 2t minus 2t into 1 plus this is 1. Therefore, this is going to get cancelled and this is going to be 1. Therefore, this function and this function is same now. This is the same as the given function. So, now this function is expressed in terms of u of t minus pi. The given function f of t is expressed in terms of unit step function. Now I have to take the Laplace transform after expressing in terms of unit step function. To find the Laplace transform, we should use any one of the formula we have derived earlier. Which are the formula we have derived earlier? We will go back to the formula. One formula is Laplace transform of the unit step function only u of t minus a. The second formula is of this form. With u of t minus a, there is a f of t minus a. That means in the function, the coefficients are in terms of t minus a, which is the same as the t minus a here. Therefore, these are the only two formula I have when I have unit step function. Therefore, either my term should be only unit step function or a function whose variable is t minus a when my unit step function is u of t minus a. So that we will come back to the problem now. Now this is the function expressed in terms of a unit step function. There is a u of t minus pi, which I know how to take the Laplace transform. There is a u of t minus pi into some function, but the coefficients are not same. The coefficient of u is t minus pi, whereas the function is only t. Therefore, I have to express these coefficients of u of t minus pi in terms of t minus pi, because we know the Laplace transform of f of t minus a into u of t minus a. When it is t minus pi, the coefficient should be in t minus pi. Therefore, we shall express the coefficients of u of t minus pi in terms of t minus pi. Now, how to do this? Okay. If the coefficients are t minus pi, we will see what extra term is to be added. Therefore, this I will make it as t minus pi. This also I will take it as t minus pi. And that is what we wanted. While we want that, what are the terms to be adjusted, we will come to know after making changes here. So 2t, this I can take the Laplace transform as it is, because there is no Heaviside function coming over here. There is no unit step function coming over here. This I can take the transform directly. But here, because there is a unit step function, the coefficient must be changed. Therefore, 2t minus 2 into this t, I will make it as t minus pi into u of t minus pi plus u of t minus pi. So, we will multiply this 2t minus 2t into u of t minus pi, minus into minus plus 2 pi into u of t minus pi, that is here, plus u of t minus pi as it is. Therefore, this gives me, what is this? This is what I wanted over here, 2t minus 2 into t minus pi, u of t minus pi plus u of t minus pi. And here, what we will do is, I will minus 2 pi u in this function. Okay, we'll come back over here. Okay, the original function is this 2t minus 2t u plus u. Therefore, 2t minus 2t u plus u. This is the original function. Therefore, this one we will shift it to the other side, or I will minus 2 pi u of t minus u on both sides. Therefore, minus 2 pi u of t minus u on both sides. These two are going to get cancelled, and right hand side I have 2t minus 2t u plus 2 pi u. 2t minus 2t u plus u. And left side, after subtracting, we will simplify 2t minus 2 into t minus pi u of t minus pi. We will combine this taking u common. If I take u common, this becomes 1 minus 2 pi. The right hand side is exactly the f of t. So now f of t Coefficients of u are expressed in terms of t minus pi. Here it is just a number, so it does not matter. When t is there, it should be t minus pi. With u, if t comes, it should be in t minus pi. Here there is no u, therefore t can remain as it is. Here there is u, there is no t over here, therefore this is okay for us. Therefore, f of t is this value now. Now we will take the Laplace transform. L of f of t is equal to L of this one. So, L of 2t minus 2 into L of t minus pi u of t minus pi minus of 2 pi minus 1 into L of u of 2 minus pi. L of 2t is 2 into 1 by s square minus, this is what? If the function is of the form L of f of t minus a into u of t minus a, then it is nothing but e power minus sa into L of f of t. Okay. What is f of t? F of t is nothing but, from here if I remove minus pi, then it is f of t. Therefore, it is L of t. Okay. I hope you can understand this. L of, this is of the form f of t minus a into u of t minus a. If I want f of t, then in t minus a, that minus a part I should leave off. Therefore, the function only wherever t I have to take. Therefore, this is L of t. Minus 2 pi minus 1 into L of u of t minus pi is what? L of u of t minus a. By formula it is 1 by s into e power minus sa. A is this number over here. Therefore, L of u of t minus pi will be 1 by s into e power minus s into a. A is this number pi. Simplify this. L of t is put as 1 by s square minus the same term over here. Open the brackets and simplify. You are going to get this answer. Therefore, this is a slightly lengthy problem, but you should be very careful in solving this. Similarly, the second one, okay, we have to express this in terms of unit step function. Because the breakpoint is 2, I have to put it in terms of u of t minus 2. What is u of t minus 2? 0 for t less than 2, 1 for t greater than 2. Now, how should I go on setting my function? F of t I will take, and the first part minus the first part into u. This is the standard way of doing it. Therefore, t square minus t square into u of t minus 2. Then I will see how what happens to my new function. F of t is equal to, when t is less than 2, first part is 0, so that it is t square minus 0. When t is greater than 2, this part is 1, therefore t square minus t square. So it is going to give me this function. This is the same, first part is same, but the second part I should make it as 6. This is the same for the given function. When t is less than 2, we need to make f of t is 6 when t is greater than 2. So to make that, what shall we do? The same function what we have set we will take. Because this is plus 6 over here, I will do this number plus this number into u of t minus 2. Then we will check by the definition. It is going to give me the same function as the given function. Now once it is expressed in terms of unit step function, wherever unit step function comes, if there is a function along with that, the coefficient should be in terms of t minus 2. There is no unit function, therefore t square can remain as it is. Here there is a unit function, therefore t must make it as t minus 2. Here there is a number which I can take the transform directly. So now we shall express the coefficients of u of t minus 2 in terms of t minus 2. So what was my function? My function is here t square. I can keep it as it is. This t square I should make it as t minus 2 whole square into u of t minus 2 plus 6 into u of t minus 2. Okay. We will simplify this here. A minus b whole square. The formula is being put over here. Multiply all the brackets. This is going to be the function what I am getting. Now we will match this with the original function and see what is the extra part. We will see which is my function and what is that extra thing I should add so that it becomes equal to this one. We have opened up all the brackets over here. Now we will match with the original function t square minus t square into u plus 6u. That is the original function. So I have here t square minus t square into u plus 6u. This after calculation, after simplification here, this is the extra term which is to be added. Therefore, if I This is f of t minus 4 into 1 minus t into u of t minus 2. Therefore, f of t will be equal to this one plus 4 into 1 minus t into u of t minus 2. Therefore, f of t is equal to, the coefficients are now changed. While changing the coefficients, this is the extra term which is to be added. Now take the Laplace transforms. Okay. L of f of t is L of t square minus L of this one t minus 2 whole square plus u into u of t minus 2 plus 6 into L of u of t minus 2 plus 4 into L of 1 minus t into u of t minus 2. Now, in this procedure, while I was solving the problem, I have made sure that with this u, the coefficient is t minus 2. But while writing this, I have observed with this u also, whatever coefficients will come, that also should be in the form of t minus 2. Therefore, in this procedure over here, the coefficients again I have changed to t minus 2. Okay. Taking L of t square, it is 2 by s cube. This one becomes, what is this? Minus e power minus s into a. A is 2. Then L of f of t. What is f of t? This only t wherever it is I should take. Therefore, this minus 2 I should ignore. Therefore, this becomes t square. Plus 6 into, taking the Laplace transform, writing the formula, plus 4 into, now I cannot apply the formula directly over here. Therefore, in the further steps, I have simplified that. This I have kept the same throughout, taking L of t square. Only this portion I have simplified here. Plus 4 into, now to make it as t minus 2, I have done 1 minus t minus 2. Therefore, 1 minus t minus 2, to balance that minus 2, what I should do? 1 minus this t, I have written it as t minus 2. Therefore, to balance this 2 is coming over here. Therefore, this becomes 1 minus 2 is minus 1. So, this is minus of t minus 2 minus 1 into u of t minus 2. Now, t minus 2 we will multiply minus of t minus 2 into u of t minus 2, then minus of u of t minus 2. Therefore, now I can take the Laplace transform, plus 4 into L of this one minus this 4 is to be multiplied into L of u of minus 4 into L of this term. Then take the Laplace transform. Here the function, if I remove this minus 2, is t, therefore L of t, and this is direct formula for L of u of t minus 2. Simplify, this is going to be my answer. You can do the simplification beforehand before taking the Laplace transform. Since I did not observe this, I have solved it in the coming steps. Then these are a few more problems which you can find the solution. Try to find the solution. Find the Laplace transforms of the following functions. This is of the form a unit step function into some function. With u, the coefficient is also same. If t minus 1 is there, coefficient also is t minus 1. Therefore, we can take the Laplace transform directly. What is that I should do? E power minus sa. A is 1 into L of, if t minus 1 is there, this minus 1 I should ignore. So, it is L of e power t. E power t is 1 by s minus 1, which you can simplify. Similarly, you can go through the remaining problems. This one, coefficient I should change as t minus 3. This one, the coefficient I should change as t plus 1. Okay. So, 1 I have left it as work example for you, exercise for you. This I have solved over here. This t, I have made it as t plus 1 minus 1 so that I can change the coefficient. So, 1 minus e power 2 into t plus 1 minus 2. Then e power a plus b, we can split the coefficient. So, it is u of t plus 1 minus e power minus 2 into e power 2 into t plus 1 into u of t plus 1. Then take the Laplace transform, L of this one minus e power minus 2 into L of this one. This is reducing to e power minus sa. This is L of u of t plus 1. 1 by s into e power minus sa. A is minus 1. Minus e power minus 2. E power minus sa. A is minus 1 here. L of, wherever there is plus 1, I should ignore. Therefore, it becomes L of e power 2t. That is 1 by s minus 2. Therefore, this is the final answer we have. So, this is about Heaviside function. Please solve the exercise problems so that you can understand the concepts better. Thank you.